This is Timothy Wood with Citadel's Civil Engineering Department. And in this presentation, I want to talk to you about the effective use of the Pocket Lab sensor in an engineering dynamics course. So Pocket Labs is a very small, low cost, about $150 a piece, classroom ready sensor package. They're really intended for K-12 education. They've got a lot of sensors on there. That we have an accelerometer, gyroscope, infrared rangefinder, and there's a whole lot more actually in the Pocket Labs sensor package. But the best part is that it pretty seamlessly integrates with their applications on the iPad, iPhone, and Android devices. And I find it very easy to use in class. So in this next little clip here, I'm going to show you how easy it is to go from turning on the Pocket Labs app to actually recording data and discussing it with students and sharing that data out. This is the Pocket Lab software on the iPad as I would pull it up in class, sharing with the main screen. In class, I would want to show a graph and connect to the Pocket Lab. And once it makes that connection through Bluetooth, you can get some live data. In order to see what's going on and share it with the screen, you can share from the iPad's camera. And so now you can see my Pocket Lab sensor and the various things. The Pocket Lab sensor has a XYZ coordinate that you can't really see in this lighting, but the Z direction is forward, Y is up and down, and it is a MEM sensor, so it's actually measuring gravity as a constant. And then X going back and forth perpendicular. In this case, we'll be looking at Y and Z. We can also come in here and we can change, let's first change the frequency. So take it from 10 hertz up to 50 hertz. And then we can take it from, we want to look at acceleration. And we want to use the rangefinder that shoots out the front. Regraph, acceleration, rangefinder, rangefinder. And that's going to let us be able to get our position, velocity, and acceleration data all in one go. So when we're ready to actually record, we hit the record button, and then we can come over here, release our little 3D printed Hot Wheels car with the Pocket Lab attached, and when we have the data, we can press stop. Now once we've done that, we can look at the data, and looking at the data will allow us to identify the points on the curve of most interest. And once we see what's going on there, we can actually explore the data a little bit. It's got a nice data explorer. From watching the video, it looks like this here is about the range of interest for us. So over at this point, we see it fall off. There's a peak due to some curvature and different things that the infrared rangefinder is seeing. Rangefinder all kinds of freaks out as it goes through the loop-de-loop, and then we get a nice steady as it coasts out. When we look at the velocity, the Pocket Labs app is actually going through and making those differential calculations as we go along. And so you can see there's a fair amount of noise. This is super helpful to help students see that it's hard to measure things. After we do that, we can also look at the acceleration. And so if we consider the acceleration data down in this bottom graph, the X data doesn't really mean a lot to us. Although I will say if we look at the X data, we can see where it kind of translates sideways as it goes through the loop-de-loop through here. The Y data would be our normal data, and the Z data would be our tangential acceleration. And so again, we can see a little bit of increase in acceleration as it falls off the loop, and then so as it slows down and goes through that loop-de-loop, slows down and speeds up. The Y data is our normal data, so we can see here where it experiences a fair amount of normal acceleration as it goes through those turns. And then out here we can see where that acceleration basically goes to zero. When we're ready to share the data, we can export it as a CSV file. We can share the video itself, or we can share a combined video shot. Although for anything longer than about 30 seconds, that's a time consuming process. And so that's the Pocket Lab software. Now this Pocket Lab is great for doing that, and we can use it to explore a whole host of dynamics properties. So when talking about, for example, rectilinear kinematic relationships, the Pocket Lab Velocity app Velocity Lab app will actually use the gyroscope. The sensor is actually mounted on the back of that wheel to give you a measurement of position, of velocity, and acceleration in real time. And then you can look at these graphs, you can pull data from them and make calculations or just talk conceptually about the various inflection points and what have you on the plot. But it makes it very real for them. And also being able to record the video is nice. So sometimes you don't want to take the time to do the recording real time, although the students certainly enjoy that. Another example would be using equations of motion. In this experiment, I have a block sliding down a ramp, and I'm using the rangefinder to keep track of its position. And so from this information, we can pull off some data points, and we can actually calculate the coefficient of friction between the block and the ramp that it's sliding down using the equations of motion. There are lots of other examples, and I encourage you to look at the paper, and really the imagination's the limit. The Pocket Labs itself actually has an educator section where various people have uploaded lesson plans and what have you. Most of those lesson plans are aimed at K-12 education, but again, there's a lot there, good ideas that we can put into practice. When students were asked if they found that Pocket Labs increased their active engagement in the class and were beneficial for their learning, they found that the response was overwhelmingly positive. They really enjoyed the Pocket Lab demonstrations. They got a lot out of them. They enjoyed being involved in generating that data. When they were asked what was most helpful, though they certainly like examples worked on the boards and they liked having an example that related to something that was done in the classroom, over 40% strongly preferred the Pocket Labs data where they got to play with it in class. So the idea of being able to do a thing in class, get some numbers, and then run calculations was very valuable to them, and they really seemed to enjoy it. Of course, the proof is in the pudding. Would they want to do it again? And so in conclusion, when asked if they hope more professors would use sensors like Pocket Labs, over 90% of respondents said yes, they love this sort of thing. They want to see more, really increase the active engagement and the environment in the classroom. So I hope you had the opportunity to read the paper. I find this to be a very helpful thing. I love that we can do it live. In fact, I was really looking forward to playing with the Pocket Labs live in front of my colleagues at in Montreal. As it is, I hope you enjoyed this presentation, and I look forward to talking with you during the conference Q&A time. Thank you.